Hello everyone and welcome to another advanced tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 3 Quadratic Functions Long Question Example 4. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let me read the example 4 question now. The minimum value of the function fx equals to x squared plus 2px plus q is negative 9 when x equals to 1. Okay, let us read the questions now. Without using differentiation, find the value of p and of q. So that is for the question part A. For the question part B, using the value of p and of q in A, sketch the graph of y equals to fx for the domain negative 3 less than equals to x less than equals to 5. So this is for the question B part 1. For the question B part 2, sketch the graph of the absolute value function y equals to gx, where gx equals to modulus x squared plus 2px plus q for the domain negative 3 less than equals to x less than equals to 5. For the question B part 3, hence state the range of y equals to gx for the given domain. Okay, so I hope you will attempt this question in the future. If you could manage to solve this question, well done guys. But if you can't solve this question, no worries, I'm going to show you the step-by-step working and the solutions now. Okay, without further delay, let us start our discussion of the solution. Start from the question part A, followed by the question part B. So let us begin guys. Let us start our discussion for the question part A. Okay. For the question part A, they ask us to find the value of p and q without using the differentiation method, guys. So how to find it? Okay, let us discuss together. So to find the value of p and q, the quadratic functions need to be expressed in the general form, where your fx will be equals to a in a bracket x plus p square plus q. Okay. So since q in this case is the minimum value, and then x plus p we're going to later on express as the axis of symmetry, which in the question they mention is equals to 1. Okay, so let us continue. So we rewrite the whole equation here, fx equals to x squared plus 2px plus q. So now what we do, we perform the completing the square, guys. And before that, please check your coefficient a here. If your coefficient a here is 1, then you can straight away proceed to do the completing the square method. Okay, so let us proceed to do the completing the square method. So from here, x squared plus 2px plus 2p over 2 square. So how I get this 2p over here? So from the coefficient b, guys, so please take a note, and then you divide with 2 and you square it. So when you square it, you need to plus and minus at the same time, guys. So that's how completing the square method works. Okay, and then you plus with q. So from here, these three expressions, so we're going to form a quadratic factor. So where you get x plus p square. Okay, why x plus p square? When you expand this, you should get back the same expression, guys, where you get your x squared plus 2px plus p squared. Okay, and then minus p squared plus q. So later on, what you're going to do, so this function fx equals to x plus p square minus p square plus q. So we're going to compare with the values given by the question, which is the minimum value and then the axis of symmetry, which is negative 9 and x equals to 1. Okay, so let us continue. So the step 2, what we're going to do is we're going to do the comparison according to the value of p and q. So how I'm going to do that? So please hold on, I'm going to show you in the next working now. Okay, let us start our comparison from the axis of symmetry. So for the axis of symmetry, x plus p is equals to 0. So to find x, what you do, the negative, this positive p, you move it over to the right hand side. So from here you get x equals to negative p. In the question, they already mentioned that x is equals to 1. So indirectly, you can form a relation such that negative p is equals to 1. So to find p, what you do, 1 you divide with negative 1. So from here you get your p is equals to negative 1. So this is your answer guys for the P. Okay, let us find the value of Q. So how to find the value of Q? Now we do the comparison for the minimum value guys. Okay, for the minimum value, negative P square plus Q is equals to negative 9. Since you know that the value of P is equals to negative 1, what you do, you substitute the P value inside this equation. Okay, from here, negative in a bracket negative 1 square plus Q is equals to negative 9. Okay, so this negative 1 square, you get positive 1 and then you times back with negative 1. So from here you get back negative 1 plus Q equals to negative 9. So to get Q, what you do, this negative 1, you move it over to the right hand side, so it will become positive 1. Therefore, you get your Q value is equals to negative 8. Okay guys, so this is the solution for the question part A, where you get your value of P is negative 1 and Q is equals to negative 8. Okay, let us proceed to the question part B now. Okay, for the question part B, they ask us to do the sketching guys of the function fx according to the range negative 3 and then the highest range of 5. Okay, for that what you need to do, you need to find all the important points. Okay, what are the important points? Okay, let me show you now all the required points we need to find. Okay, we need to find the lowest range, highest range value, and then y-intercept and x-intercept, and at last we need to find the maximum point or minimum point depending on the question guys. Okay, in this case we are finding the minimum point over here. Okay, let us start to find the lowest range value. Okay, so when your x is equals to negative 3, so this is your lowest domain guys. Okay, when x equals to negative 3, so this is your fx, where your fx is equals to x square minus 2. Originally was negative 2px minus 8. Since you already find your p from the P and Q from the question part A, so you substitute directly over here, where you get x square minus 2x minus 8. Okay, let us continue. So from here you substitute this negative 3 into the fx. So you get negative 3 square minus 2 in a bracket negative 3 minus 8. So you calculate this, you should get 7. This is for the lowest range. Okay, the same thing for the highest range. Okay, when x equals to 5, fx equals to x square minus 2x minus 8. So you substitute the 5 into the equation. So 5 square minus 2 times with 5 minus 8. So you calculate this, you should get 7. Okay, so we have already calculated for the lowest range and highest range. Okay, let me turn to the next page for the remaining working. So please hold on for a moment. Okay, continue on to the next step. So for the next step, what we're going to do, we're going to calculate the y-intercept. So to calculate y-intercept, what we do, we set our x equals to 0. When x equals to 0, so 0 square minus 2 times with 0 minus 8. So from here, you get your y-intercept is equals to negative 8. Okay, once you've already calculated your y-intercept, let us continue to find our x-intercept. So to calculate your x-intercept, what you do, you set your fx equals to 0 guys. So when fx equals to 0, x square minus 2x minus 8 equals to 0. Okay, from here you're forming a quadratic equation guys. So to find the x-intercept, what you do, you perform the factorization method. So you factorize this quadratic equation. So from here you get x minus 4 in a bracket, x plus 2 equals to 0. Okay, and then from here you get 2 x-intercept value, which is x equals to 4 and x equals to negative 2. Okay, let us continue. We still have 1 point left guys, which is the minimum point. But then the minimum point they've already give in the question. How you can say that? Okay, the minimum value they've already give is negative 9. The axis of symmetry they've already give us is 1. So we can combine them to form a minimum point guys, which is 1 and negative 9. Okay, we have all the sufficient point. So let us start to sketch the graph, which I've already sketched for you. Okay, this is how your sketching will look like. So let me show you the diagram now. Okay, So your sketch should look something like this. So this is your function fx equals to x squared minus 2x minus 8. Start from the domain -3 up to 5 with the respective lowest range and the highest range. Okay, this is your respective x-intercept, this is your y-intercept, and this is your minimum point. Okay, you have all the sufficient point, and then what you do, you just sketch the graph. Okay, so sorry guys if my drawing is not that good enough. Okay, so let us proceed to the next question. So for the next question, we need to find the gx equals to modulus of x squared minus 2x minus 8. So this function, as you can notice, they are pretty similar, except for the one thing, they add the modular sign over here. Okay, what is this modular sign means, guys? Okay, this modular signs mean whatever negative value you input, the output will be written as a positive value. Okay, so that is what it means. Okay, the same method. Okay, you calculate all the respective ranges, guys. So when x equals to -3, okay, -3 square minus 2 times with -3 minus 8, and then you modulus it. So from here you get 7. Okay, so no effect. So proceed to calculate the highest range when x equals to 5. 5 square minus 2 times with 5 minus 8. So you calculate this, you should get 7. Okay, let me turn to the next page for the remaining working. So please hold on for a moment. Okay, once you've already find for the lowest range and the highest range, okay, now you proceed to find the y-intercept. Okay, for the y-intercept, you set your x equals to 0. When x equals to 0, so f0 equals to 0 square minus 2 times with 0 minus with 8. Since you get -8 as an output, so it changed back as a positive value, which is 8. So from negative value, it changed back to the positive, guys. So that is the function of the modulus. Okay, let us proceed to find the x-intercept now. So for the x-intercept, you set your fx is equals to 0, guys. When fx equals to 0, modulus x squared minus 2x minus 8 equals to 0. So this modulus sign, you move it over to the right hand side, so it will become plus minus 0. Okay, for your information, 0 is neither a positive value nor negative value, guys. So this plus minus 0 has no effect. Okay, so you just write here 0 itself. So I'm writing this for the working purpose, guys. So x squared minus 2x minus 8 equals to 0. You perform the factorization. Okay, the same step. So x minus 4, x plus 2 equals to 0. You should get x equals to 4 and x equals to -2. Okay, but then your minimum point 1, -9 will be changed to maximum point instead, which is 1 and 9. Why 1, 9? Due to the modulus effect, like I mentioned, guys. So from here, let us perform the sketch for the gx function itself. Okay, let me show you the diagram now. Okay, this is the finished sketch, guys. So as you can see, this is the clear difference between the function gx and fx. Like I've mentioned, whatever value you put as an input over here, no matter what value you key in, you always get a positive value, guys, at the end. So this is the clear difference between the function gx and the function fx. Okay, so but this is not your final working. Okay, even though you have already finished sketch, you still need to find the range, guys. So for the range of the gx will be 0 less than equals to gx less than equals to 9. Okay, why 0? 0 is the lowest possible value and 9 is the highest possible value according to this range, guys. So that's why you set your range such that 0 less than equals to gx less than equals to 9. So this will be your final answer. Okay, let me put back the question paper for your reference. So please hold on for a moment. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Thank you everyone for your support, and I'll see you in the next video.